Good afternoon, everyone. In this video, we'll be discussing about sockets with non-blocking IO operations. Okay. So the basic socket API, whatever we have seen, actually provides asynchronous. So that is non-blocking send operations. We have been seeing these things and blocking receive operations. Okay. So a process that actually reads from a socket, okay, in that case is actually subject to blocking. The problem we have seen several times. Okay. The best approach to basically avoid this one is like you can actually employ threads for that. Okay. So one thread like you will create which will be actually waiting for this sort of reading the data. So that is like this thread is actually blocked for basically that receiving operation, and another thread for basically the processing other task. So this we have already discussed when we were discussing about event synchronization. Okay. Conceptually, how do we avoid this sort of blocking? And of course for our blocking as well, you can avoid with that one. Okay. So that's about this sort of basic socket API. But however, like when your application has a lot of threads, okay, so these threads actually incur some overhead because you are doing that context switching and everything. Okay, so whenever like your application is really cramping for performance, okay, so the threads are a little bit problematic. So they actually reduce the performance of the application. Okay, of course threads are very good. Say for example, instead of creating a new process, threads are much more lightweight. Okay, but then like even further like you want to improve the performance of your application, then threads are a little bit not so great. Okay, there are socket API that actually provide this sort of non-blocking IO operations. Okay, so the fundamental idea is basically the receiving process. Okay, the sending process is actually sending, the receiving process. Basically the receiving process need to use some sort of listener to be notified of the arrival of the data. Okay, this we have actually discussed while discussing this sort of event synchronization. Okay, so then you are not blocked, so your receiving don't have to be blocked, so it can basically continue further whenever like it has actually received the data, it has to be notified by the listener. Okay, so we have also seen this one when we discussed about event synchronization, when we were discussing about synchronous send and asynchronous receive. Okay, and we have seen three different types there. Of course, like asynchronous sockets are available with WinSock. Okay, WinSock API basically supports that one. Java also has this java.nio. So non-blocking IO basically offers these sockets with non-blocking IO. So let us look at Java NIO a little bit in detail. Okay, NIO is actually a buffer-oriented and channel-based approach for IO operations. Okay, in standard IO API, the character streams and byte streams are actually used. So whenever you are using the streams, probably you all know about that one. Whenever you are using java.io, there will be streams. So for example, a sender will be actually writing to the stream, and then like the Java program, like you have basically have to read from the stream. Similarly, you will be writing to the stream. Whenever you are writing or reading from the stream, like you are actually reading bytes or characters one after the other. So that's how like basically in the basic Java IO, both this sort of reading and writing become like blocking. Okay. But with this sort of Java NI, there will be buffers and channels which will be existing. Data is always written from a buffer to a channel. Okay. And then like actually it is read from a channel to a buffer. Okay. So buffers are always existing in the middle between the channels. Okay, so I'll be showing that with a diagram, and also like we'll be seeing an example there. So thus Java NIO basically provides this feature of non-blocking IO. Okay, so application returns immediately with whatever the data it has available, and the application should have this sort of polling mechanism to basically find out when more data is actually ready. That's what we have seen in the earlier slide as well, which we have discussed in the event synchronization when we were discussing that topic in chapter 2. Okay. So along with these sort of channels and then like these buffers, NIO also supports these selectors. So selectors are the objects that can be used for monitoring multiple channels. For the events like say for example data has arrived in that particular channel, or like a connection is actually opened, etc. So with these sort of selectors, a single thread can basically monitor multiple channels for the data. Okay, NIO is extensively used in file handling. Okay, so if people are interested, I definitely encourage you to basically look at this reference and then like know more about this Java NIO. Okay, so non-blocking IO. So we'll be looking at non-blocking IO. Okay, so and we will see some of the examples as part of this video. So these are the channels and buffers. Okay, so data sink or data source, from where like the data is actually stored. Okay, and from where it is actually read as well. Okay, so these are data sink and data source, and you have your Java program which is actually is doing the actual task. So you have these buffers and channels. So whenever, like, say for example, you are trying to write data, okay, so that like the data is actually stored in data sink, okay, so that is actually pushed. So basically, like, you will write, the Java program will write the data to a buffer, okay. This is the buffer which is existing here, and the channel, okay, actually reads from this buffer. Okay, you got that one. So it is not the other way around. I mean, like, it is not like you are writing to it and then like the buffer, from the buffer, like you would write to the channel. Okay, so it is the other way around. Java program actually writes to the buffer, and the channel actually reads from the buffer. Okay, similarly, whenever like your Java program actually has to read a data, so that means like the channel actually is actually acting as the data source. Okay, so the channel actually writes the data from the data source to the buffer. Okay, so this is what the channel is actually doing, and of course, like, once the data is there in the buffer, the program will actually read it from that particular buffer. Okay, there are several types of channels which are possible. So primary channels which are actually used are datagram channel. Okay, so the same way like we have seen datagram packets, datagram sockets, you will be reading the data using this sort of UDP protocol. That's for the datagram channel. And the socket channel and server socket channel, the exactly the same way, like we will be creating the server sockets at the server side. Okay, and the socket channel is actually used for this sort of reading data via the sockets. Okay, server sockets and server socket channel and socket channel. These two things also, like, we will try later, but first, like, we will also see like what is about file channel. When you have the file channel, like, you can actually read and write to the files actually using the file channel. Okay, similarly, using the socket channel, you will be reading and writing from the socket channel. So there are several types of buffers possible. Java NIO basically supports these core buffers. Okay, so these are character buffer, double buffer. So every basic data types, okay, which are supported in Java, it has its own buffer type as well. Char buffer, double buffer, int buffer, long buffer, okay, short float, etc. As I already mentioned, like, when it is streams, like, you always will be reading from the streams and writing to the streams. So you are actually blocked. Here in this case, like, the buffer are actually being populated in the background. You don't have to wait for them. Okay. Let us try to see the file channel demo. So here is my file transfer class. Okay, so I am basically trying to read the data from multiple files, and then like I am trying to write it into one single file. Okay, so basically, like, here are my input files. So basically, like, I have text there, hello everyone, and then like welcome to distributed computing course, and then like happy learning. Okay, so I am reading this content from these multiple files, and I want to write it into a single file. How do I do it? With this sort of file transfer. Okay, we using these file channels actually. Okay, so using Java NIO. So basically, like, you can see in the packages, like, you have this sort of Java.NIO channels. So file channel, and then like we will also use like writable byte channel. So basically, like, what I'm doing is like I'm reading these file names. Okay, so this is just adding them into a string array. Okay, and then like I'm creating another file which is for the output. Okay, so all of them are in the temp folder for me. Okay, what I will be doing is like the usual way, I will be creating this file output stream. Okay, and then like I will be getting this file from the output file name. I'm creating a file, and then like I'm creating a file output stream first. Okay, so basically I have created like this writable byte channel, and I got it from this sort of file output stream. Okay, so using this sort of output dot get channel. Then what I am doing is like as long as I have more number of files there, so I am looping over those that string array. Okay, so and then like I'm getting like each and every file. So the first file, so I'm using this sort of file input stream. From the input I will create this channel. Okay, because like from the file I am trying to read, so I'm creating this sort of input channel for me. Okay, so that is the file channel which I am creating in this input channel. Okay, from the input channel. Okay, so basically like eventually it will be written to the buffers. Okay, but then like in this demo, like I'm not using the buffers. What I'll be doing is like I'll be taking the data from the input channel and then like I'm writing, transferring it to the output channel. Okay, to the target channel in this case. Okay, so that's the basic idea. So from the input channel I am transferring the data to, so whatever the input channel data I have. Okay, so that is the size. Okay, so from 0 to that much of size, this is actually the buffer from where, so the channel, the buffer is actually read. You are not seeing the buffers, but in fact actually in the background the buffer is there. So up to this sort of input channel length. Okay, so whatever the thing like which you have read it from the buffer, I am actually pushing it to the target channel. Okay, so this is how like I am getting this sort of input channel from this sort of file input stream and then like writing it to the file output streams channel. Okay, so of course once that is done, then I am closing the input channel and I am also closing the input, so which is the file input stream for that one, and I am repeating this for all the file names. Okay, so and once all the files have written the data to the output stream channel, so output channel, so that is like this writable byte channel, so I am closing that sort of target channel as well. Okay, and this is how like I am actually reading from all the files and I am writing to that one file, and all the operations here are non-blocking. Okay, if you would have used plain streams, then you will be reading, then your process has to wait for that one. When you are writing, your process have to also block for that one. In this case, you don't have to do anything. Let me try to run that one. Okay, so basically like it has run. So let me try to refresh this one. So all the content is actually written into this sort of combined output channel, combined output file, actually combined output text file. See, it has read from all the different files and then like it has written to that one. So this is how you can actually use the channels using Java and IO. So good. Now we have seen like how the channels can be used and then like how the buffers can be used. Okay. Of course, in the background buffers are actually used in the background for you. But how the channels can be used for this sort of file reading. Okay. So we have used file channel and also like write byte channel as well. Okay. Now let us try to look at the selector. Okay, and also like in the process we will also be looking at this socket channel and server socket channel as well in the example. So basically the selector, as I have already mentioned, like selector is actually monitoring all the channels, so that like when there is a data is coming or when an event is actually happening, this is the one which is actually monitoring for those particular events. Okay, say for example if there are multiple channels and you have one selector. Okay, how do you basically know like an event has occurred on a particular channel? Okay, for that one like selector has this sort of selected key set. Okay, so we can actually access these sort of ready channels by using this sort of selected key sets, and you can actually get each and every key and which actually will identify that particular channel where like that particular event has actually occurred. Okay, so once you have this sort of keys. Okay, so basically like the selector is actually monitoring for all the channels and then like it is actually generating those particular keys when an event is actually occurring. So then the process can actually process each and every key, okay, in a sequential manner. So then you don't need the threads actually. So everything is actually happening in the non-blocking way. Okay, so unlike threads, like no context switching and separate stack allocations are required in this case. So everything is sequentially processed here. So let me try to demonstrate that one. In the process also will demonstrate like how the java.nio provides these sort of non-blocking sockets for you. So for that one, like we'll be using this server socket channel and socket channel for that one. Let's try to see the demo. So here is my server socket channel example. Okay, so that means like here is my server and here is my client. Okay, let me first explain this server first. Okay, so what I am doing is like first I am selecting I am creating a selector. Okay, so and then like I'm creating I'm opening the selector, so that means like it is actually monitoring, it is ready for that one. So selector is open for making the connections in that case. Okay, then what I will be doing is like I am creating a server socket channel. So the same way, like we will be creating the server socket, okay, in this server side. So I need to basically create that channel, and I will be opening that channel. And then like just the way like I have created, so I will create an inet socket address, okay, so with this localhost and the port number, okay, and then like I will basically bind this server socket channel to that particular address, okay. So that means like then the server socket is actually created on the localhost on port number 8080. So that means like on 8080 it is waiting for accepting the connections, okay, eventually. Right now like all you have created is this just a channel, and then like you have bound that channel to that particular address, okay. And of course like we are basically configuring the non-blocking socket, so basically we are setting it as false. And of course like since it is a server socket channel, like you will basically get all these sort of valid operations, okay, so you will basically get them, okay. So these are the operations which are actually used for the keys actually. So basically once you have this sort of server socket channel is there, then you will registering this server socket channel with that particular selector, because the selector is the one which is actually monitoring multiple channels, okay. So the server socket channel is actually associated with that particular selector there. So you will register to the selector, and these are the operations which you are allowing, okay. So valid operations, basically register that one. Of course once this sort of server socket channel is actually created, then in a forever loop you are actually doing that one. So basically you are waiting for the select operation, okay. So basically like whenever like the selector dot select, you are actually trying to see like how many keys are actually created, okay. The number of selected keys are so many number of keys. So that means like whenever there is an event is happening, it is actually creating a key for you. So always like you are trying to see like how many new keys are actually created. That's what is this for loop for you. And whenever like there are more than some keys, okay, so that means like an event has happened, okay, you are actually getting this sort of keys. And selected keys, you are actually getting that set of these selected keys, okay. So once you have that set, so you can actually use an iterator to loop through all the keys, isn't it? So you basically get the keys as a set, and then like you can have an iterator to basically loop through all those keys whatever are created at that particular event. So of course, so while there are more keys, okay, so this is how like you have to iterate over the iterator, okay. So idr dot has next, okay. So then you are actually trying to select the key, whatever, by using this sort of idr dot next, okay. You are actually getting the selection key, and if the key is of the type is acceptable, because you have created a server socket channel, so that means like you have created a server socket. So the type of events there can be like an accept, okay. A connection is actually coming, so then you basically will be accepting that one. So this we have actually seen when we have seen the server sockets in the plain API. So in the same way, when the key is actually is of the type is acceptable type, then you create a socket channel the same way like we have created a socket by accepting that connection. So on the channel like you are accepting the connection the same way like server socket dot accept, okay, which will create a socket for you. In this case it is creating a socket channel for you. And of course like this this socket channel, like whatever you have created, again like you are setting it as non-blocking channel, okay, non-blocking socket for you, okay. And again like this socket channel, now whatever is created, now you have to register with that selector, isn't it? That's only when that selector will be. Right now like the selector is actually monitoring only the server socket channel. Now whatever the new socket channel which you have created, you want the selector also to monitor that one as well, okay. That's what you are doing. So with this sort of the socket channel, like you are actually registering with the selector with this selection key type or operation read. So now basically from this sort of socket channel you will be reading. That's the operation you are basically assigned of that particular key type, okay. For the server socket channel you have attached all the valid operations already, and for this one like you are registering only the read, okay, for this socket. Of course like now the new connection is accepted from the client, you are just printing it out. And when the next time like whenever data is actually read, okay, in that particular socket, okay, So now this selector will basically say like, yeah, now I have received a data operation. So that means like it is not if the type is acceptable. Now the new key generated is of the type readable. Okay, whenever you are trying to read it, so you will basically get the channel. Okay, from the key, like you can actually get the channel which is of the type socket channel for you. And now you will create a buffer. You see, byte buffer you will actually create, which is actually you have allocated some length of 256 bytes. Okay, so basically like once you have that sort of buffer, so you are actually reading from that buffer. Okay, so basically like buffer dot array, and then like you are creating a string out of it, and that is the message which you have read, and then like you printed that message. If the message is of the type bye bye, okay, so then you are closing that sort of client socket channel, which is the client. Okay, and we are basically saying that the client messages are complete, and then we are closing the session. This is what the server socket is actually doing, the server socket channels, basically using the selector. The client is also the same. So all you will be doing is like, now you will create an inet socket address. So you are trying to connect to the local host on port number 8080. That's where the server socket is existing. You will create a socket channel. Okay, so and then like you will actually open on that particular address. Okay, so the socket is created, the socket channel is also created for you. So then the client is basically saying like sending the messages, and it is actually taking some messages. So time goes fast, what next, and then like eventually it will end with bye bye. Okay, and it is taking this array of strings, and then like each array, okay, it will create this sort of get bytes from that string. Okay, and these bytes are the ones like which it is actually trying to wrap it into this sort of byte buffer. Okay, and then like it will write this buffer, okay, into this particular channel. Okay, which will be eventually put into that particular channel, and then like it will basically go towards this server socket. Okay, so that's what you are doing, and then like you are creating the buffer. Okay, so that like all the data is actually written, and then like you are waiting for some 10 seconds. So you are sending each and every message, and then like you are waiting for 10 seconds just for us to see. And once all the data is actually sent, you are actually closing the client. Let's try to see that. Okay, so in execution, as always, you will start the server first. So let us try to start the server. So that means like, yeah, the selector is open for making the connection. So that means like you have created the selector, and you also have created the server socket channel. And now let me start the client, and let me start the client for you. So basically like both of them are running on 8080. So basically like time goes fast, it has written the first message, and let me see it on the server side. So basically it has received one message, and it has read the thing. So okay, so it has received all the messages. So basically like you can see both the consoles one after the other. So the client is the one which is actually sending the messages. So let us see the console of the server side. Okay, what it has done in total. So first it has basically waited for that selector is created, and it is open, and then like it has basically got an event. Okay, so that means like that event is of the type accepted type. So it basically has accepted that client. Okay, so the socket channel like which it has received is 127 on the port 80. The client socket was created on a random one, which is on 52815 port on the local host itself, 127.0.0.1. So that means like now at this level, like we have both the channels, okay, associated with that particular selector, okay, at this time. And then again, like it was waiting for the next operation. Next operation was a read. So this time like it was a read operation. So the message was actually read from the client. So which is time goes fast, okay. And then like again like it waited for some more time. Okay, so for the next operation again was a read. Okay, so it again printed what's next. Okay, so then it waited again. This time again another read has come. This time the message was of the type bye bye, so it has actually closed the thing. Okay, so this is how like you can actually use this sort of Java NIO socket channel and server socket channel for non-blocking sockets. So regarding the references are concerned, we are still in chapter 4 of distributed computing principles and applications. Okay. If you want to know more about Java and IO, I am leaving a reference here. Actually, I encourage all of you to go through those information. Thank you very much for your attention.